Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 11, Section 1, Part 1A. So we are starting this thing called stoichiometry. So what will you be able to answer at the end of this unit? How can we calculate the amounts of each chemical needed for a reaction? How much of each chemical will be produced? Why is it important to know the amounts of reactants and products? Do chemists follow a recipe like when they're mixing chemicals? So, in class we're going to take a look at page 327. So section 1 talks about analyzing a chemical reaction. So what does that mean? And I feel like we're really digging into chemistry now, so I'm excited for what we're going to do. Okay, please write this down. Stoichiometry is the study of the amount of substances involved in a chemical reaction. So we can't just put things together. You need to know how much of what we're putting together, because you need a certain amount of product, or it needs to create a certain amount of heat, or it can't create more than a certain amount of heat. So knowing the amounts is really important, and that's kind of what we're looking at now. So if we look at this, so please write down this chemical equation. 2 moles of liquid water decompose to form 2 moles of hydrogen gas and 1 mole of oxygen gas. So please write this down. 2 moles or molecules of liquid water decompose into 2 moles or molecules of hydrogen gas and 1 mole or molecule of oxygen gas. So if you notice, we could do it in mole ratios, or we could think about these as actual molecules. So the moles of each element are conserved, but not the total amount of moles. So if you look, you have 2 moles of water, and then you have 2 moles of hydrogen and 1 mole of oxygen. So you might say like, oh, there's 2 moles here and 3 moles over here, so how does that work? But we have to look at each atom, each element. So you notice we have 2 times 2, 4 moles of hydrogen and 4 moles of hydrogen and 2 moles of oxygen and 2 moles of oxygen. So that's how that works. Okay, in class we're going to look at page 329, and we're going to do a little, look at a little PowerPoint. Okay, so let's take a look at this. So chemical equations tell stories, like 2 moles of carbon monoxide gas react with 1 mole of oxygen gas to form 2 moles of carbon dioxide gas. And we can put the stories into different categories, just like we can put stories into nonfiction, science fiction, adventure, romance, history, psychology, children's literature. We can put the stories of chemical equations into different categories, like synthesis, decomposition, single replacement, double replacement, a precipitate reaction, a polymerization reaction, an acid-base reaction, a combustion reaction, so on and so forth. So just a quick review, we know synthesis, A plus B equals AB. And what does it tell us? They tell us what compounds, the reactants we start with. They tell us what compounds are formed, carbon dioxide. And they tell us how much of each compound is involved. And that is stoichiometry. So you don't need to write any of this, you just kind of need to follow along. Alright, so we know that there are 2 carbon monoxide molecules and 1 oxygen molecule, and that forms 2 carbon dioxide molecules. So the 2 is the ratio. It could be 2 molecules, it could be 2 dozen, it could be 2 moles, but the ratio of 2 to 1 to 2 is really important. So it could be 2 moles or 2 molecules. And then we know a mole is 6.023 or 22 times 10 to the 23rd, and so then that would be that many molecules, so a lot of molecules. So you might be like, oh wait, this is 3 and that's 2, but we already talked about it. It's each atom. As long as there is a balanced chemical equation, then all of the atoms will be balanced. So that's why we spent so much time working on balanced chemical equations. So we know on this side, we have 2 carbons, 2, 4, and then 4 oxygens. And we're really interested in the coefficients in stoichiometry. We really want to know the coefficients. So for instance, let's say we're baking and we're going to make a cake mix and 3 eggs and a 1/4 cup of oil and 1 cup of water, and that's going to make 1 batch of cupcakes. So we need a 1/4 cup of oil to make 1 batch of cupcakes. So the ratio is 1/4 cup oil over 1 batch cupcakes, which is the same as 1 batch of cupcakes over a 1/4 cup of oil. So it doesn't really matter the order, they are equivalent to each other, so you can put either one on top. But if you know when you're doing a problem, the order does matter because you need to cancel units out. So you have to figure out which unit do I have to cancel out to figure out which one goes on top, which one goes on the bottom. So if I have 4/4, I have a full cup, I'm going to make 4 batches. So 1 cup of oil over 4 batches, or 4 batches over 1 cup of oil. So let's look at a chemical equation. The fermentation of sugar, C6H12O6, ferments into ethanol, 2 moles of C2H5OH, and 2 moles of carbon dioxide gas. If we notice, our ratio is 1 yields 2 and 2. So if I have 3 moles of glucose, I will form 6 moles of ethanol and carbon dioxide. If you notice, the ratio 1 to 2 to 2 would be the same as the ratio 3 to 6 to 6. And I could keep going. So you have to multiply by the same number because the ratio of the coefficients has to stay the same. So these coefficients, the ratio of the coefficients, are stoichiometrically equivalent. Like 1 mole of glucose will make 2 moles of ethanol. And so those mole ratios are going to be really important in some calculations we're going to do. So let's take a look at mole ratios, a ratio comparison between 2 substances in a balanced equation. It's obtained from the coefficients in a balanced chemical equation. So that seems like a great place to head back over to our notes. Okay, please write this down. A mole ratio is a ratio comparison between substances in a chemical reaction, and it's obtained from the coefficients in a balanced chemical equation. It's very useful in solving problems. I'm going to move the frame over. Great, that's a little more centered. So please write down this equation. 1 mole of carbon monoxide gas reacts with 2 moles of hydrogen gas to form 1 mole of methanol, CH3OH, which is liquid. All right. And I'm going to make you write down this whole sentence, sorry, but we won't be doing that for very long. To make 1 mole of methanol, we need 1 mole of carbon monoxide and 2 moles of H2. So 1 mole of carbon monoxide and 2 moles of hydrogen are proportionate amounts in this chemical equation. So 1 mole of carbon monoxide makes 1 mole of methanol. 2 moles of hydrogen make 1 mole of methanol. Those are equivalent numbers for this equation. So please write down this. 1 mole of carbon monoxide over 2 moles of hydrogen is equal to 2 moles of hydrogen over 1 mole of carbon monoxide, just like 1 dozen eggs is 12 eggs, or 12 eggs is 1 dozen. So again, the order is dependent on how we set it up in a problem, how the units need to cancel. All right, using mole ratios, we're going to do a mole-to-mole calculation. So please write down the steps. First thing we're going to do is write a balanced chemical equation. Always start with a balanced chemical equation. Then we're going to figure out the mole ratio. So we're going to put our unknown number over our known number. We're going to set up the problem and calculate. The moles of your known quantity over 1 times your mole ratio of your unknown over your known equals your moles of your unknown. All right, let's tackle it. A mixture of aluminum metal and chlorine gas reacts to form aluminum chloride. How many moles of aluminum chloride will form when 5 moles of chlorine gas react with excess aluminum metal? So please write that formula or that problem down. Okay, first thing we need to do is write what we know. So let's do that. Okay, welcome back. All right, so what do we know? We know we have 5 moles of chlorine, and we're trying to figure out how many moles of aluminum. So let's write that down. 5 moles chlorine, and so it's going to be chlorine gas. And then we're trying to figure out how many moles of aluminum chloride. Uh-oh, that's an important part. Al, and so we'll need to write the formula for chloride. Aluminum has a +3 charge, so it's going to be AlCl3. I'm going to rewrite this. How many moles of aluminum chloride? Okay, our next step is to write a balanced chemical equation. So let's go back and look at this. A mixture of aluminum metal and chlorine gas reacts to form aluminum chloride. Well, I know I have aluminum metal, which is going to be solid. I know I have chlorine gas, which is a diatomic element. I know that's gas. It's going to form aluminum chloride. That's a ionic compound, so it's either solid or aqueous, but there's no water, so it's going to be solid. Now I have to balance this. I have 2 chlorines here and 3 chlorines there, so the common multiple of 2 and 3 is 6. So I have to put a 3 here so that I get 6, and a 2 here so I get 6 chlorines. But now I have 2 aluminums, so I need to make 2 aluminums there. Then we have to figure out the mole ratio of our unknown over our known. So our unknown is what we're going for. We're going for moles of aluminum chloride. So moles AlCl3 over our known, which is chlorine gas. All right, I'm going to fix that up just a little bit. Okay, now we need to figure out the mole ratio. You're going to be tempted to put in 5 moles of chlorine. That is not the mole ratio. The mole ratio is not in the problem. It's always, always, always in the balanced chemical equation. So I have 2 moles of aluminum chloride and 3 moles of chlorine gas. So you always get it from the balanced chemical equation. Then we're going to set up our problem and solve it. So moles of our known. Now we go to our problem. 5 moles chlorine. Okay, I took the liberty to finish writing it to save a little bit of time. So 5 moles of chlorine over 1 times our mole ratio, 2 moles of aluminum chloride over 3 moles of chlorine. Moles chlorine cancel. I have 5 times 2 over 3. I'm going to round that to a tenth, and I get 3.3 moles AlCl3. Okay, we're going to check over that in class, and you get to try it, so please write this down. How many moles of ammonia are produced when 6 moles of hydrogen gas react with an excess of nitrogen gas? And please do the problem. I'll see you then.